Welcome all. In this session, we are going to discuss about the construction materials. In that, we will be discussing about the structural steel. So far, we have discussed about its advantages, disadvantages, and what is the purpose of using structural steel in applications, and its composition, and its classification based on its carbon content and all. And also, we discussed about its physical and mechanical properties. Right. Now we are going to discuss about some of the remaining portions. First, we are going to discuss about the types of the structural steel. Okay, so basically we are going to discuss about five types. First one is a standard quality and its corresponding code is IS 226. Okay, it is designated as FE410S. S stands for standard quality. We all know what is that 410 means. 410 means it's grade. Okay, so the percentage of carbon content is about 0.23 to 0.25 percentage in this standard quality steel, and its percentage of elongation is about 23 percentage. For riveting and bolting, it can be done for all the thicknesses. Okay, whatever may be thickness of the steel, it can be riveted and bolted. But welding can be done only for the steel having thickness less than or equal to 20 mm. Okay. Next, they are used in buildings, bridges, and some of the industrial structures, and also for the transmission line towers. Next, we are going to discuss about the fusion welding type. Okay, so here they are designated as FE410. Since this is welding type, so they have mentioned as W. They are classifying it to three. One is A, B, C. That is what it is designated as FE410WA, FE410WB, and FE410WC. Here the carbon content is about 0.20 to 0.25 percentage, and the percentage of elongation is same as the standard quality, that is 23 percentage. But here the welding can be also done for all the thickness of the steel. There is the restriction. Okay, in standard quality steel they are given some restriction for the welding, because the welding can be done for the thickness only up to 20 mm, but here there is no restriction according in respect of the thickness. Okay, these steels are used when the structures are susceptible to the dynamic loads. Dynamic loads means like a bridge decking, okay, girders, and crane girders. There and all we will be using this fusion welding type steel. And third one, we are going to discuss about the high tensile steel, and its corresponding code is IS 961. It is actually designated as 570, FE 570 HT and FE4 540 HT. Okay, here FE 570 HT means fabrication will be done other than fusion welding. Okay, in FE 540 high HT only fusion welding will be done. In FE 570 HT fabrication will be done along with the fusion welding, whereas in FE 540 HT only fusion welding will be done. Okay, so this offers greater strength, and also it is a highly resistant to the atmospheric corrosion. Then the percentage of elongation is about 20 percentage, and its carbon content is about 0.27 percentage. And the remaining two are, one is ordinary steel, and the fifth one is medium and high strength quality steel. For ordinary steel, IS 1977 is the corresponding code, and for the medium and high strength quality steel, IS 8500 is the code, Indian standard code we are preferring. Next, there are various types of steel sections over there. Okay, steel can be rolled into variety of sections, but here we are having some of the 10 types of the rolled steel sections. First one is rolled steel I sections. Mostly they will be using this I sections for beams, so only they are mentioning as I sections or beam sections. And second one, rolled steel channel sections. Third, T sections, angle sections, hollow section, bars. You know what is meant by bars? Steel bars. We'll be using in the reinforcement, that is called steel bars. And steel flats, steel plates, steel sheets, and steel strips. Okay, in the next upcoming slide you will be knowing what are all these types of steel. Okay, Okay, see, this is the T section. We all know what is the shape of the T will be. Okay, this is the structural steel. So this its cross section will look like T. So that only it is named as a T section. In channel section means on the last you can see it will be in the shape of C. Okay, that is called the channel section. Its cross section will be in the shape of C. Here I have given the longitudinal section that here you can see here. Wait, let me explain. You can see this is the cross section. Am I right? This is the cross section. This is your longitudinal view. Okay, so this gives the shape of the T. Here you can see what is this? This is in the shape of C. Similarly, this is I section. It will be in the shape of I. Okay, you can see here they will be providing some fillet here. Okay, so this I won't be like this. You can put I like this also. Okay, sharply you can cut. Here you can see you can sharply cut, but they are not doing that. What they are doing, they are giving some fillet. Okay, it's like this. It's like this. Can you tell me why? Because there will be some amount of bearing stress. Okay, to avoid the bearing stress only, they are providing this fillet in the beams. Okay, to avoid the bearing stress, they are providing fillet in the beams. So you can see the box section. You can name the box section as hollow steel section also, which is nothing but the hollow. You can see inside there is empty. You know the meaning of hollow, right? Inside there will be nothing. That is called hollow section. So this is the hollow steel section. This is in the shape of the box. We can also say it as a box section. Next, this is rolled steel I sections. Okay, this is the designation for the rolled steel I sections. So they will be giving like this: ISCB 500 at 736.8 Newton per meter, which means 500 means its overall depth. Okay, the beam's overall depth is designated as there as 500 here, and that 736.8 Newton per meter denotes the self weight of the beam. Okay, this is the standard sizes of the beam. There will be some standard sizes for the beam, and there are some types of I sections. One is ISJB. ISJB means Indian Standard Junior Beams. Indian Standard Junior Beams. ISLB means Indian Standard Light Beams. Indian Standard Light Beams. ISMB stands for Medium Weight Beams. That is Indian Standard Medium Weight Beams. ISHB means Indian Standard Heavyweight Beams. Indian Standard Heavyweight Beams. ISWB means Indian Standard Wide Flange Beams. Wide Flange Beams. And you may ask, what is the purpose of these different types of I sections, right? ISJB is used in vehicles. They will be using this for vehicles. And ISLB, that is the light beams and the medium weight beams, they will be using this to transfer the load from the floor to the beams. Okay, from the floor means from the ceiling. Floor means you should not think that the floor, it means the first floor, which means the ceiling for the ground floor. Am I right? So it transfers the load from that floor to the corresponding beams. And if it is a ground floor means what? That floor will be connected to the lintel, right? So it will be lintel beam will be there, F beam will be there. For that they will be transferring the load. For that purpose they will be providing this kind of beams. And this ISWB, that is the wide flange beams, they will be using this in gantry girders. Gantry girders. And the maximum depth of I section available is 600 mm. Okay, maximum depth of I section available is 600 mm. And here you should note one more thing also. We are having various types of sections. Okay, so we must know which section offers more strength. We are having I section, channel section, T section, angle section and all. Let us discuss about in the next slides and all. Next we are having channel section. Okay, channel section will be designated like this: ISLC 350 at 380.63 Newton per meter means the same thing here also. Okay, I section and channel section are similar in their designation. 350 denotes the overall depth of the channel. Okay, whereas that 380.63 denotes the self weight of the channel. You should know here these are all the standard conditions. They will be giving these things in the standard manner. Okay. So there are some types of channel section. One is ISJC. The same here, Indian Standard Junior Channel. ISLC means Indian Standard Light Channels. ISMCP means Indian Standard Medium Weight Channel with parallel flanges. Okay. Indian Standard Medium Weight Channel with parallel flanges. ISMC means medium weight channel with a sloping flange. Previously we had parallel flanges. Now here it is sloping flanges. Next, ISGC means gauge channels. Indian Standard Gauge Channels. Okay. Next we are going to discuss about the rolled steel angle sections. Okay, there are three types of angle sections. Before discussing about that, let us discuss about the designation on the right corner. Okay, angle sections are usually designated as ISA 125 cross 75 cross 10 mm means that 125 cross 75 mm denotes the leg width. Leg means in this image you can see L, they have mentioned no, this x-axis direction there one outstanding leg is there, and in the y-axis direction one outstanding leg is there. That is named as leg. Okay, its width is denoted as 125 mm and 75 mm. Okay, whereas thickness is mentioned at the last, that is 10 mm. This is the usual designation of the angle sections. But there are three different types of angle sections. One is equal angle sections, and another one is unequal angle sections. Third one is bulb angle sections. Okay, equal angle sections we can give designation as ISEA or simply ISA, because by for unequal angles you will be giving only ISA. You see, the common designation is ISA. Okay, for both of these we are using ISA. We won't get confused, because here if it is 125 cross 75 means you will be knowing that this is an unequal section, because here 125 and the L2 leg 2 value, leg 2 width is what? It is 75. So both are not equal. It is unequal angles. Suppose think this is 100 mm. Okay, L1, that is in case of 125 I am substituting 100, and 75 is also 100 means 100 cross 10 mm means what? It is equal angles. So it can be commonly designated as ISA. It won't confuse you. Okay, but when you are coming to bulb angles means what happens? It is designated as ISBA. Okay, this equal angle means, so you understood by this designation itself, this both the leg will be equal, both the length of the leg will be same, that is called equal angles. If both the legs are having different values means they are named as unequal angle sections. Okay, sometimes in this angle sections they will be providing some bulb, you can see here. Okay, let me point out and say, wait, yeah. Here you can see one bulb. Okay, this is called bulb angle. Sometimes they will be providing this bulb here also. Okay, so it is possible to provide the bulbs at both the ends of the legs. Okay, so this is called bulb angles. These are mainly provided in the ship constructions. Okay, these unequal angles will resist tension. Is capable of resisting tension. Unequal angles are capable of resisting tension, whereas the equal angles are capable of resisting compression. Okay, let's move on to the next slide. Okay, this is rolled and one more thing, in angle section you should note one more thing. For the same cross section area, if you are having the same cross section area and weight means, an equal angle section gives a higher minimum moment of inertia. Okay, you will be calculating I minimum. Okay, so it will be very higher. That I minimum will be high for equal angle section. And the radius of gyration above the minor axis will also be high for unequal angle sections. So what they have concluded is that equal angle section is best to resist compression member for rolled steel angles. Okay, that only we have discussed there. Let us discuss about the rolled steel. Next, let us discuss about these rolled steel bars. Okay, they are actually They are actually in two types. One is round bars and another one is square bars. Mostly, we will be seeing this round bars in any construction site. You would have been seen, right? It will be in round. Its cross section will be in round. See, this steel bar is in rectangle. I mean, it may be in a square shape. Okay, so this ISRQ means Indian Standard Rectangular Bars. Okay, by seeing this name itself, you can name easily. This is Indian Standard Square Bars. This 20 in IS orbit 20 means that 20 denotes the dia of this bar. It means it is a 20 mm dia bar. Okay, so if it is square bar means this 50 mm denotes the sides. You're having sides here. You're not having any dia in this square, right? So it denotes the 50 mm dia. Okay. And next, some of the steel cross sections are there. One is steel flats. Steel flats, they are designated as 100 ISF 10. In that, 100 denotes the width of the steel and 10 denotes the thickness. Okay. And rolled steel plates, they are designated as ISPL 2000 cross 1000 cross 10 mm means that 2000 denotes the length, 1000 denotes the width of the plate, and 10 mm denotes the thickness. You can see the thickness is often provided at the end. Okay. So best tension member the best cross section that resists tension is the flat sections. Okay, flat section, that is this rolled steel flat, because there will be less eccentricity and the buckling strength will be less. Okay, if the eccentricity is less means the buckling strength will be less. Okay, can you understand? See, this is some rectangular column I may take. This is your CG. Okay, usually at the center of gravity the load will be acting. Some special places will be there. It's not special place. Usually any real life structures, there won't be any load acting on the center in the column. That is, in the centroid, no load will column. It will be acting somewhat outward to the centroid. See, this is your CG. So here I am having some distance, right, between this center of gravity and this load. It is denoted as E. E is nothing but the eccentricity. Eccentricity means it is the distance of the load from the center of gravity. Okay, so this, what happens, this eccentricity is capable of creating a moment, and it will create some buckling property in the component. So the buckling strength will be lesser when there is eccentricity. Okay, so it is better to provide a flat section to resist tension. If it is a tension member, it is better to provide a flat section. Okay. Next, you are having a rolled steel sheets. Okay, it is designated as ISSH. 1000 cross 600 cross 2 mm. You don't confuse that these are the only standard cases. That is this 1000 cross 600 cross 2 mm is the only available rolled sheet, and it's not the thing. There are various sizes are available there. For example, we are discussing only about the one size. Okay, ISSH means Indian Standard Steel Sheets. Same here also, like the steel plates, steel sheets also. First term, that is the 1000 denotes the length, 600 denotes the width, and 2 mm denotes the thickness. We all very well know that angle section is good for compression. You should never forget that. And you will be asking that where we are going to use the steel plates. They will be using the steel plates above the beam section. Okay, to increase the moment of inertia. So I have already told you that we are going to discuss about that moment of inertia, to compare all these sections. Okay, I mean we are going to compare the 4 sections. You just wait. See, this is your I section. This is your I section. It will be having some moment of inertia. Similarly, T section will be having some moment of inertia. Channel section will be having, channel section means it will be in the shape of C. T section is this. Okay, I'm just drawing like this, but you should not draw like this. It will be like this. Okay, this is T section. This is your channel section, and it won't be like a cross fit. Okay, it will be like this. It will be little curved. That is, we are providing some fillet to overcome the bearing stress. Okay, fillet is provided to be overcome the bearing stress. When comparing these four sections, what they have concluded is the moment of inertia about the x-axis for the I section. Okay, moment of inertia for I section is greater. Okay, is greater than moment of inertia for channel section. Okay, moment of inertia. Next comes the moment of inertia for the channel section. Okay, and then it is the moment of inertia greater than the T section, which is also greater than the moment of inertia of the angle section. Angle section is denoted in the letter L. Okay, it will be looking like this. Am I right? It will be looking like this. So angle section is denoted using the letter L. So moment of inertia of I section is greater than the moment of inertia of angle channel section, and it's greater than a moment of inertia of T section, which is in turn greater than the moment of inertia of the angle section. Okay, so from that, so what they are concluding is, if the moment of inertia is I, means what happens, the beam will be capable of carrying more weight. Okay, it can resist more transverse loads. To resist more transverse loads, there should be more amount of moment of inertia about the major axis. Okay, so if they have to resist lateral loads, means the moment of inertia should be more for the section about minor axis. So we are discussing two different loads. One is lateral loads, another one is transverse loads. If it is a lateral loads, means moment of inertia should be high. Okay, it may be a transverse loads or it may be a lateral loads. Okay, if it is a lateral load, means moment of inertia about minor axis should be high. If it is a transverse loads, means moment of inertia about the major axis should be high. Okay. Generally, in column design, they will be using ISHB, that is heavy weight beams. I think when discussing about the types of I section, I didn't mention that. So you write it down. We have discussed that that junior beams were used in vehicles, light beams and medium weight beams are used to transfer the load from the floor to the beam. Okay. Similarly, that heavy weight beams will resist the, it is used in the column design. Okay, so we found that the moment of inertia for the I section will be high, so it is capable of so it is good to adopt that I section, right? So coming to the steel plate, so this is here comes your I section. Okay, my I section is very poor, please adjust. So what I'll be doing, I told you that I'm going to place that steel plate above this I section. Okay, they will be placing the steel plate above the I section. Say its a thickness would be T. Okay, so this is your center. So what will be the distance? D by 2. Correct? It will be D by 2. Using this, actually they will be placing this, you don't need to know that formula and all, it's a tougher thing and it's not important in this exam point of view, also in this gate point of view. So just understand that steel plates are used above the I-beam section, especially when the beam is a very large span beam. Okay, because it will be able to resist, which means it will be able to produce more amount of moment of inertia. Whenever I am placing that steel plate over the I section, means what happens, the moment of inertia value will be increased. Okay, moment of inertia value increased means what? The strength of the beam will be increased. For that purpose only, we are going to place that steel plate over the beam, I beam. That too, whenever the span is too high, for that cases only we will be placing. Okay, and also one more thing we should note here. here we have that hollow sections, right? These hollow sections are designated by their outside dimensions and thickness. Okay, they will be designated using their outside dimensions, not inside dimensions. You know what is mean by outside dimensions and inside dimensions? I think so. Okay, we are having this hollow sections, right? You know what is mean by hollow. Let me take one rectangular section. What happens? This is the cross section view of your hollow sections. So here nothing will be there. This portion will be empty. Okay, this is your thickness. This is your thickness. This section thickness. Okay, so when you are taking this rectangular sections means you will be having the outside dimension. Outside dimensions means from here to here. Okay, if it is inside dimensions means how you will be marking it? From this portion to from this portion. It is marked as inner dimension. Okay, this is how this green color denotes outside dimension. This is the inner dimension. You will be deducting the thickness on the both the sides accordingly, and you will be getting the inner dimension. So whenever you are giving some designation to the rolled steel hollow sections, or you can also call it as the tube sections. Okay, you should always use the outside dimensions and its thickness. You should not mark the inside dimensions. Okay, you will be having three types of hollow sections. One is rectangular and another one is square. Third one is circular. The circular hollow section is better than circular solid section because the radius of the gyration will be more for the hollow section. If the radius of the gyration is a high means the moment of inertia, that is the I minimum, will also be high, so that it is capable of resisting the compression. Okay, so for in which we found that in equal angle section, that okay, while comparing the angle sections, equal angle sections will be resisting the compression, whereas unequal angle sections will be resisting tension, we found. Okay, in addition to that, one thing generally they will be telling that angle sections is good for compression. Okay, like that they will be telling. And one more thing you should note here, the circular hollow sections are also will resist the compression. And one more section that is capable of resisting torsion is box section. Box section means nothing, it is the square hollow section. Okay, this box section is capable of resisting torsion because there won't be any shear center or there won't be any eccentricity problem. So that it is capable of resisting, this box section is capable of resisting torsion. In hollow sections, the compression and tension will be the same. And one more thing you should note here, this closed sections will be always strong in tension. These kind of closed sections will be always strong in tension. Okay? And this is your assignment questions. You should solve this. Once if you watch the video only, you will be able to solve this assignment questions. Okay? So please watch the video fully and then solve the assignment answers. All should submit your assignments. Here you see some of the questions were from aptitude. Okay, so it will be not too tougher. If you feel any toughness in this, you just ask me. I will be explaining. These questions are very simple. Once you listen to the class, it will be very easy. Okay, so the final question is, this is a justification question, or it may be application question, or it may be your understanding questions. Okay, whatever it may be. The final question you see, say for what reason we go for structural steel as a reinforcing material. Okay, we are having so many materials, so many, you'll be telling that it's a tensile member, we need tension in concrete for that purpose. So many tension members are there. I mean, many tension metals are there. Why we are going for structural steel? That is very important thing. Okay, so you find the answer for that. Whatever you know, you just write it. I will explain in the next class that why we are using the structural steel as a reinforcing material, and also why we are using the structural steel itself in the structural application. Not only as a reinforcing material, you are using the steel itself as a structural member, right? That will also I will explaining. Okay, so you should submit the assignments. to the same mail ID that I have given in the previous video lecture itself. Okay, so do it, and thank you all for watching. Thank you.